Okay, I've got the solution hidden. So here we are. So here we are. In many cameras, the built-in flash gets its energy. So basically, what the flash is, it's got a tremendous amount of resistance in there because basically it's a small little gas tube. And basically, what you're creating is you're creating lightning within that tube. You're making a small little. Remember the Jacob's ladder we're about to class? You're making a small little Jacob's ladder inside that tube. All right. So you need to charge up a capacitor. And so ah ah on one end of the tube, hold on. I'm waving my hands and I want you to see it. So anyway, let me make it a little bit smaller so I can get that red dot out of there. All right. So anyway, hey, this pen has a blank cartridge in the middle of it, right? So the pen has a blank cartridge in the middle of it, and positive charge are more negative, and I got to charge this thing up and charge it up and charge it up, and then it's like the Jacob's ladder, and boom, the electrons are built up so much in here that and they got the less the more positive side over here that these electrons gas tube, and when they get through that gas tube, it cool shit, isn't it? So anyway, and so that's how you get your flash. So you get that extra light to expose the film, which gets us into the optics. And anyway, so um, everything else is stamp collecting, as Rutherford said. Anyway, all right. In many cameras, the built-in flash gets its energy from that stored in the capacitor. The capacitor is charged using long-life batteries with voltages typically 9 volts. Once the bulb is fired, the capacitor must recharge quickly through an internal RC circuit. Okay, so um, it, I think the 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 resistance within this circuit is going to be kind of small. So if you read in the text, you see that the human body's resistance was like 1,000 ohms or something like that. This is going to be kind of small ohms. Now, to get through that gas tube, you need to charge up. That's probably got a resistance to get to basically make lightning in a bottle. You'd have to have a tremendous amount of resistance is what's going through there. So you need a tremendous amount of energy to get that thing done. So the resistance is huge. It's like when lightning hits a tree and it burns it in fire, right? Okay, so enough on the introductions. Let's write down what we've got here, and that'll be all. These things here will be written, and then we'll solve. So what we have to do is if the capacitor has a value of zero point 0.1 farads. That's a pretty big capacitor, actually. What must the resistance be so that the capacitor is charged to 80% of its maximum charge to fire the bulb again within 5 seconds? Okay, so when t equals 5 seconds, we want it to be charged up to 80%. All right, so that's what we're going for.